Okay, today we're going to solve rational expressions. So remember that solving means to find the value of x when y is 0. Sometimes we call it solving, sometimes we call it finding the x-intercepts or the roots or the zeros, right? They all mean the same thing. So for example, solve for the value of x when y is 0. So we've replaced y with the 0, and it also wants us to state any denominator restrictions, which is because we cannot divide by 0, so we need to indicate the values of x that would make that denominator 0. So when I am solving, well, these ones are pretty simple because you only have one term, so we can just cross multiply. And when I cross multiply, that means that the denominator is going to be multiplied by 0, and all that will leave me is the numerator. So when there's only one term, the numerator is going to determine your x-intercept, and then we're just going to solve for x. So there's my solution. I also want to state any restrictions. So my restrictions are based on the denominator. So this denominator cannot equal 0. I'll have to factor to determine that. So I have two factors, so either x can't be 0 or x cannot be 2. And then you will notice that my solution is also one of the restrictions. So that means that I have no solution, because although I did solve for x, that value is going to give me an undefined answer, and so therefore there is no solution. So always make sure that you check your restrictions and make sure that that's not one of the solutions. Okay, here. Solve for the value of x. So I've already replaced y with 0. I'm going to cross multiply, which leaves me with just the numerator. If I want to solve it, I need to factor. So 4 times 1 is 4. It would be minus 4 plus 1. And then I'm going to take each factor, set it equal to 0 to solve it. And then we're going to do our restrictions just to double check that those solutions are valid. So this denominator cannot equal 0. And I'll need to, it's much easier if I factor it. So 4 2s are 8, both negative. So x can't be 4 and x can't be 2. And then I just want to double check my solutions. I see that one of my restrictions is also a solution. So that means this is an invalid solution. So the only solution I have is x equals -1. Okay, so there's that. And then one more, cross multiply, x times 0 is 0. Factor to determine the values of x. So 9 times 8 is 72, would be plus 9 minus 8. So either x equals -9 or x equals 8. Those are my two solutions, and then we'll check our restrictions. I only have one term in the denominator, which is 0, so x cannot equal 0, and that is not one of my solutions, so both solutions are valid. Some of your terms will have more than one. Some of your equations will have more than one term. So that makes it a little trickier because now I can't just cross multiply. So I have to figure out a different way to do it. It's the easiest way to do it. You could find a common denominator and add all the terms together and then cross multiply. Perfectly fine. You can also just clear the denominators by multiplying by the lowest common multiple. So the lowest common multiple is similar to finding the lowest common denominator. So if I were to find the lowest common denominator, it would be 4 and k. So I'm going to multiply all terms by 4k to clear these fractions out. So in the first term, maybe I'll just write it out here. So times 4k and then times 4k. So in the first term, the 4's cancel, and I will be multiplying the numerator by just k. In the second term, the 4's cancel. And I'll be multiplying the numerator by just k. And then in the last term, both the 4 and the k cancel. And I don't have to multiply that by anything. Okay, so that step eliminates all the denominators and it makes it much easier to solve. So now I will expand brackets. And we want to solve, so we need all terms on the same side. So I'm just going to bring them all to the left. So I have 2k squared. I have plus 2k, right? 4k minus 2k, and then I have minus 4. Then I want to factor, so I see there's a common 2, so I'll take that out. And we have a simple trinomial. So 2 times 1 is 2, and it would be plus 1, or plus 2 minus 1. And then we'll just solve. So k equals negative 2, and k equals 1. And then don't forget to check your restrictions to make sure that your restriction is not also a solution. So my restriction is 4k cannot be 0. So therefore k cannot equal 0, and that is not one of my solutions, so both my solutions are valid. Okay, so multiply all terms by the common multiple, and then it just becomes a matter of solving as you did with the other questions. Okay, so I'm going to do the same thing here. I want to clear these fractions. My lowest common multiple would have to have a 2 and an m squared. So I'm going to multiply all terms by 2m squared. So in the first term, the 2m squared reduces with the 2m squared. So we're just left with 1. In the second term, one of the m's cancels. So we're left with 2m times 1. And then in the third term, the 2's cancel. And we're left with m squared times 1. So I'm going to actually bring everything to the left because I like to have my m squared positive. I don't like starting with a negative, so that'll be plus. 2m will be minus, and then we have a plus 1 there. And then we'll just factor. So both would be negative 1, so therefore m equals 1. And then our restriction, we just have 2m squared can't be 0, so m cannot be 0. Okay, so that is not one of my solutions, so my solution of m equals 1 is a valid solution. Okay, the lowest common multiple here, just be careful. You can't combine these. My lowest common multiple would have to have a 5 for this term, well, a 5x. And it would have to have 2 x's for that one, and it would have to have an x plus 1. So that is my lowest common multiple. It has to contain all of the denominators, and you don't want to multiply them together, you just want to have them separately. So I'm multiplying all terms by 5x squared and x plus 1. So in the first term, the x squares will reduce. So I will be left with the 5 and the x plus 1 multiplied by the numerator. In the second term, 5x is canceled, so that will leave me with 1x and the x plus 1 times the numerator of 3. In the last term, the x plus 1 will cancel, so that will leave me with 5x squared times the numerator. Okay? So in this term, I'm going to expand brackets, so that's 5x plus 5. Here we have negative x times 3 is negative 3x squared, and then we have negative x times 1 times 3 is minus 3x, and then on this side we have 5x squared. So I'm going to bring everything to the right. So 5x squared plus 3x squared is 8x squared, and then I have minus 2x, and then I have minus 5. Just make sure this is correct. Okay, once we have that, we can just factor. So it's a complex trinomial factor, whatever works for you. I'm just going to do this. So I'm going to try 4 and 2, which gives me 8, and then 5 has to be 5 and 1. So let's see. If I put 5 and 1, that gives me 6. If I put, so that's not going to work. So 8's not going to, or 4 and 2 is not going to work. So let's try 8 and 1, 5 and 1. That's not going to work. So if it is not factorable, we can always use the quadratic formula. Okay, so not factorable. So we're going to use the quadratic formula to solve for x. That's a perfectly reasonable way to do it. So we have b is -2. And then we have -2 squared minus 4, a is 8, c is -5. And then 2 8s are 16. All right, so let's see what we get. We get 2. We get 4. Negative and negative is positive. 4 5s are 20 times 8 is 160 over 16. So we get 2 solutions, 2 plus the root of 164 over 16, and 2 minus the root of 164 over 16. And we can just leave it, you could leave it in exact form if you want. You could simplify the rational expression. If you want to leave it in exact form, I would need to change 164 to a mixed radical. So 164 is divisible by 4. So that would make it 2 root 41 over 16, and then I could reduce that to 1 root 41 over 8. So I could leave it in exact form, or you can do it in decimal form. Either answer is acceptable. Divided by 8. So one answer would be 0.93. And the other answer would be -0.68. So either answer is fine. If you leave it in exact form, just make sure it's in mixed radical form. Okay, so let's do another one. So you would need to factor this in order to determine the lowest common multiple, because we don't want to double up. We don't want to have more than we need. So if I factor this, then I could see that this one also has an x plus 3 and an x minus 1. Oops. So I don't want to have a lowest common multiple that's bigger than I really need. So when I factor it, I see that the lowest common multiple would be x plus 3 and x plus 1. Okay? So in the first term, both the x plus 3 and x plus 1 would reduce. Right? So both of these would reduce in the first term, and we would just be left with the numerator. In this term, just the x plus 3 would reduce, so we'd have an x plus 1 left. And then in this term, just the x plus 1 would reduce, so we'd have an x plus 3 left. Okay, so that reduces all those denominators, and then I'm just going to simplify by expanding brackets. Be careful of signs in this last one. I'm subtracting, so I'm going to multiply the two binomials together first before I apply the negative, just so I get my signs correct, because we don't want to mess up on our signs. So I'm going to put the terms to the left so that my x squared is positive. So what do we have here? We have plus 5x. and then we have plus 6. So I know I can factor that into 3 and 2. And x equals -3, x equals -2. And then I'm just going to check restrictions. My restrictions, well, my restrictions are x cannot be -3 because that was a factor in the denominator, and -1. So this one is invalid because it is a restriction, right? So this one's not possible, so x equals -2 is the restriction. Did we do our restrictions in the previous question? We did not. So my restriction was x. Forgot to state them here. So x can't be 0, and x can't be -1. So that was not one of our solutions, so we were fine there. Did we do it in the previous question? We did. Okay, so that is solving.